Hello everybody, my name is Joachim Gassen, and on behalf of the whole offer team I welcome you to our little tutorial on how to reproduce our paper, How Does Carbon Footprint Information Affect Consumer Choice, which is forthcoming in the Journal of Accounting Research. Following the principles of open science, this paper comes with a GitHub repository containing everything you need to reproduce our analyses, and this is what you're currently seeing here. The link to it is in the description. In this repository, we offer 3 different options on how to reproduce our analysis. The third option would be the traditional one, where you would have to set up everything locally. This can be quite a chore, and this is why we also offer you the option to use development containers. And this is most easily done using GitHub Codespaces. GitHub Codespaces is a cloud development platform offered by GitHub to everybody who has a GitHub account. It currently comes with 30 hours a month of free usage. We're just using a little bit of these 30 hours here to show you how to code along and how to reproduce our analysis relatively quickly. In order to use GitHub Codespaces, all that you would have to do after logging onto GitHub and navigating to our repository is to click on this little wonderful green button that you see just in the right upper part of the screen. There you can set up a GitHub Codespace on the main branch of our repository. This normally takes maybe 4 to 5 minutes, and we cut this down here so then we can get to the more exciting stuff quickly. I would urge you to consider using GitHub Codespaces not just to reproduce our stuff, but also maybe for your own development purposes, because it's a great way to develop on multiple platforms and also to make sure that your code is reproducible by others. If you want to have your own local development environment, then I recommend you take a look at the other options, but I suggest that you start with this because it's simply the easiest way to get our code up and running. Now you see the development environment, and it's basically Visual Studio Code in a browser, and you also see the README file from the repository. Now the first thing that we already did is we started this development environment, and now we are ready to reproduce the analysis, and this is relatively easy. So it will create data in the data generated folder, which is currently empty as you see, and it will also create output in the output folder, which is also empty. And in order to create all the results, you simply have to use the command make all in the terminal. So this is what we're currently doing. And now you see that the make routine is basically starting a bunch of scripts. And you can see the first script, for example, just generated some samples out of the raw data. The raw data is in data external. And then the next step is building the material for the power analysis that we did for the registered report conference HR. Now you see that after this has been done, the next step is actually creating the pre-registered analyses, and this is being executed right now. Since this produces a bunch of different files, these files are being zipped in the folder. You can see them showing up in the output folder as I talk. We do also in the paper, we do present results for different specifications where we define, let's say, the unit of analysis a little bit differently. So you would have to read the paper in order to understand this in detail. And you now see that we also had some additional analyses that we did, and these are also stored in the output folder, again in zip files. And towards the end of this whole process, we also run the specification curve analysis. This is in part building on static files. Read the README for more detail. Now we're done with running the code already. This actually was not sped up. And now we can look at the data and at the results in the respective folders. I want to take a peek into the pre-registered results, and for this we need to unzip them. So we can do this right within the browser because we installed some extensions for you. So meaning that here we create a new folder, and in this folder we unzip all these result files from the pre-registration version. So these are the results. So these are figures in different formats and also some HTML. For example, here you will see our favorite figure that also made it into the paper in the end. And that's the paper, that's a figure that displays on each treatment day the CO2 that has been consumed. So you've seen it, and you've also seen the clipping in the paper. Now, this is our main result. Again, it's in an HTML file that you just produced, and you also see the original table in the paper for comparison. Now, another thing that you might be interested in is our specification curve analysis, where we also have this little dashboard that is also available online. Again, the link is in the comment section if you just want to click and watch. But here now, with this repository in this environment, you can actually build your own local version of this dashboard and run it in your very own browser. And this is what we do here. So again, we are sourcing some code here, and the code then generates this dashboard, and dashboard is simply then linked to the browser. You've seen that. Now here again on the right hand side you see the figure as it is in the paper, but the good thing is now we no longer have just a figure, we have something dynamic where we can basically zoom in onto different specifications. And this is what we're doing right now. You see that I'm excluding options step by step. For example, here, I just make sure that we only have one way to define the treatment change. And this is the one way that we also use in the paper. You can see the paper result by these dots that are a little bit larger. And now I'm limiting all these choices to only 4. And when we are down to 4 choices, actually this dashboard generates the respective regression tables instead of these nice curvatures. And this gives you the option here to explore results that didn't make it into the paper. For example, here we have a result that would manifest if we would not restrict each treatment day to stable dish choices, because towards the end of the dining day, sometimes the dish choices were a little bit changed to avoid leftovers, and we exclude these periods in our main analysis, but here they are included, and you can see that the results are relatively similar. Yeah, so they are comparable. So meaning that this design choice that we made doesn't really affect our findings too much, but you can dive into detail. But reproduction is of course not just about making sure that the code runs, it's also about being able to change things. And for this, I just want to provide you a little example here. And this little example is centered around the regression analysis, and we will include an additional control variable, because why not, right? And one easy way to do this is simply to browse into the code. What this does, this little command browser here in R, it will open up an interactive debug session at a certain point. And here this is convenient because the point is right before regression models are being estimated, so it should be relatively easy for us now to change the regression model. Now, the data that is being used for the regression, this is in a temporary data frame called df. And we can open this data frame. You see this now on the right. And you see how the data is being structured right before it's used for analysis. So some sample restrictions already have been applied. And here, for example, you see the dish choices. And here you see how many dishes people have been eaten. And here's a new variable which didn't make it into the paper, actually. This is the variable to go. It indicates whether people ordered or got their food on a to-go container instead of a real dish that they could use in the canteen. You see that this is a very rare choice. Only 277 cases we observed that people actually use these to-go containers and also built them at the cash register. And first of all, we are interested to understand whether this maybe depends on the type of diners, because maybe the busy faculty and other staff, they would be more likely to use these containers, whereas students can enjoy the cafeteria in full blow. So what you see here hints a little bit into this direction if you want. So the share seems marginally higher for faculty, staff, and guests than it does for students. But maybe overall, these numbers are just very small. And this is also why we decided not to include this variable in the paper. But still, now that you have the data available, you can do this. And we do this by just looking at the regression models that already include controls. This one here, for example, for CO2 emissions. And now we estimate this model for starters, and let's just look at the results from that model. This is also a convenient way for us to double check that we actually have the right model and that we are making the right changes. So here, now you see the summary of the model as our output. For comparison, this is the model in the paper. Don't get confused by the stars, by the way, because R uses by default a slightly different starring system compared to what we do here in the paper. Okay, now what we do here, you see this, we simply edit this command and add our new variable to go, right? Now we can estimate that model and we can look at the modify model. And now you see in the bottom row, you see to go, and you see that, oh yes, people that order to go spend more CO2. That's interesting because it's also sizable. It's quite a big difference. So first order speculation is that maybe these people just order more food because it's to go. Maybe they can, they can eat in the quiet of their office, and maybe they have more time, or maybe they even want to take it home for dinner. Who knows, right? So let's check whether they also eat more food. And here, this is the model for reference here that we report in the paper. And now we see this model with an additional control variable. Oops, a little typo, so we need to fix that. Okay, here we go. And then we see, yes, indeed, they eat more food. They eat more in terms of grams, right? Now, this is interesting, but not really the scope of the paper. But you might wonder whether maybe, just maybe, this also has an effect on our treatment, whether people that order to go are less likely to be treated. Maybe because they fear less social pressure, right? Of course, they can eat in the privacy. They can eat beef in the privacy. Who knows, right? So this is the model that we estimated, which interacts the treatment effect. And you see that this treatment effect actually is not affected by the CO2, by the to-go decision. While this is comforting, this is certainly not the only analysis that you can do based on the data and the code that is included in this repository. And this is why we did this little tutorial. So we can only encourage you to code along and to try for your own. The only thing that you need is about half an hour of time maybe, and a GitHub account. Because with this GitHub account, you can press on the little green button, code, and then again, just start a development environment in Codespaces, and then just go through this video step by step, and you will see that you can relatively easily get a grip on what we do and extend our stuff. And if you come up across something interesting, hit us up. And also, of course, if you have anything to share about this approach, if you are interested in how to use it for your own projects, get in touch or use the comment function of YouTube down below to share your views. In any case, thanks for watching and have fun.